So in this video, we're going to talk about hypothesis testing, something that you will see in a statistics course. And this will be part 1 of 2, and typically when you talk about hypothesis testing, you'll even talk about it over an entire chapter. So I will do more examples, talk about more hypothesis testing as we go along. But in this video, what we're going to talk about, so this is going to be an introduction. We're going to talk about the basic idea of what we're doing, some concepts, some terminology. We'll talk about what's known as the null hypothesis, which we abbreviate as H sub 0, the alternative hypothesis, H sub A, and then we'll talk about what are known as type 1 and type 2 errors, and then we'll also discuss some other ideas. So a quick little remark, again, this is just an introduction to concepts. I don't actually perform a statistical hypothesis test in this video. So if you're looking for something, worked out, dig around for another example because I will certainly have those as well. Okay. So what do we mean when we talk about hypothesis testing? And I really like this topic because it really starts tying to me a lot of what you see in statistics together, right? You talk about normal curves, central limit theorem, deviations, all of these other things. And this is something that you can really go out there and just apply in the real world relatively easily as long as you can collect some data. And this is the power of statistics. So, Okay, so hey, that's life, as we say, right? So every day we make decisions, right? We're always making different decisions. They could be minor, they could be major. I made a decision to make this video. I procrastinated, and then I thought, okay, hey, Patrick, it's time. And, I thought about, these alternatives. If I don't do it, I know that I'm not working. That's not good. And I know based on past evidence, Patrick, it's a good idea to go make a video. So let's apply this to a different situation. Suppose that I'm throwing a party and I say, hey, why don't you come to my party? And you ask yourself, well, should I go to Patrick's party, right? Yes or no? And you think about it and you try to come up with a decision. So in this case, let's suppose, right? There's just one of two things. Either you go to the party or you don't go to the party, right? There's nothing else you can do here. And you think about maybe some past parties that I had. Maybe you had some other plans and you're like, would I rather do that? And eventually you come up with, well, a hypothesis. And hypothesis, right? We talk about these in science all the time. We're doing the same thing. So what we're going to do is we're going to identify something of concern, and in this case, that is to go or not to go to the party, and we're going to have two hypotheses. And a hypothesis is simply a statement that something is true. Okay, that's going to be our hypothesis. So in this case, we could come up with potentially some different hypotheses. So, for example, we could look at the statement, Patrick's party will be epic. Right? Patrick always has the best parties. That's going to be one of our hypotheses. So that is a hypothesis. And we could come up with the other one. We'll say, that party's going to be uber lame. It's going to be a total dud. And suppose it's one or the other. So either, my party is going to be the best ever. It's going to be great. You're going to have a wonderful time. Or it's going to be totally miserable. One or the other. Now, okay, so here we're just introducing the ideas. You'll see that when we actually start performing these hypothesis tests, we're typically going to be looking at something numerical in nature. And again, we won't do one of those examples just yet, but you'll see that in a following video. So what's the big picture here, right? That's what we want to know. So let's talk about these statistical hypothesis tests. So what is that? So this is a process by which a decision is made between two opposing hypotheses, right? My party is going to be great or my party is going to be terrible. And when we do this is something that's important. We form the hypotheses so that each is the negation of the other, right? They're mutually exclusive. Either my party is great or it's not great. It's one or the other. So what we do is we're going to test. So this is now we're kind of getting to the idea here, and we're going to talk about this over and over. We're going to test one hypothesis. And what we want to do, we're going to we hope that we can show it to be very improbable. And that's going to give evidence, but not proof that the other hypothesis is likely true. So maybe I can test the hypothesis that Patrick's party will be lame. And somehow I can show that the probability of my party being lame is really, really small. It's really improbable that my party is going to be lame. Well, then that lends a lot of evidence to saying that, well, my party is going to be really awesome. So it doesn't prove that it's going to be awesome, but it gives a lot of credibility, a lot of credence to that idea. That's the whole notion of what we're doing here. Okay, so let's talk about this again. So either A or B, but not both, must be true. Party's great, party's terrible. So we can show that A is almost certainly not true. If we can show that A is almost certainly not true, that means that B is most likely true. It's what we said a second ago. If we can show that the party is almost certainly so if we show that the probability of the party being bad is very small, that means the opposite is most likely to be true. So what do we call these? Let's introduce this terminology. So we have what's known as the null hypothesis, which we abbreviate as H sub 0, and then we have this alternative hypothesis, which we abbreviate as H sub A. So the null hypothesis, this is going to be the hypothesis that we test. And I would say, in a sense, we're sort of testing them both, right? You're kind of getting information about both things, but this is the hypothesis that we're going to test. And this is the statement that a population parameter has a specific value. And this is what I was saying a second ago. Typically, it's going to be something numerical in nature, is what that statement says. So that's our null hypothesis. Patrick's party is going to be great. The alternative hypothesis is going to be a statement about the same population parameter, and this is going to be a statement that specifies the population parameter has a different value. Again, because we want these hypotheses to be mutually exclusive. And again, we're not doing a numerical example. We're just talking about our quote-unquote real-life example. So we are hand-waving here just a little bit. So suppose our null hypothesis, H sub 0, is that Patrick's party will be epic. The alternative is that it's going to be really lame. So let's look at another example in a little more detail, and we'll talk about some other ideas here. So suppose, you're doing your grocery shopping and you wonder whether that expensive, right, you've seen ads for it, that expensive store brand soap, you wonder whether that does a better job cleaning, or that expensive store brand soap, you wonder if that does a better job cleaning compared to the generic store brand. So you're looking at the more expensive soap compared to the generic soap. And you wonder, is it worth spending that extra money? And maybe you've got some friends or you've seen some stuff, and your idea is you suspect that the expensive brand is in fact better. So maybe it's worth ponying up that extra money because you'll get better results and it'll be better in the long run. So, okay, and this is not always the case, but one little remark, we often choose the alternative hypothesis to be what we suspect to be true. Okay, so in this case, using that idea, our null hypothesis is that there's going to be no difference in performance, right? We're going to say, I don't think there's any difference in performance. That's going to be our null hypothesis. Our other hypothesis is what we suspect to be true, is that the expensive brand is in fact better at cleaning. Okay, so which one's better? So, okay, right. Now we have to talk about some things. So let's talk about what can happen in this situation, right? Because no one's perfect and neither are our statistical tests. So I think this is interesting. It's a little philosophical. So, okay, so we've got our null hypothesis and we have our alternative hypothesis. Now let's think about what can happen, right, in this situation. We've got our null, we've got our alternative, and for each one of those, we can either accept it based on the evidence that we collect, or we could reject it based on the evidence that we collect. And again, that means based on this hypothesis test, this statistical test that we will perform. Now, and based on that evidence, because we're taking a sample, this is the important part, right? We can't look at every, usually every item under consideration. So we're going to take a sample in general. And when we arrive at that decision, there is no difference between the brands, or the expensive brand is better. That decision, well, it may be correct or it may not be correct, right? Either we've done a good job or we haven't. We've chose poorly. Okay. So again, what was our null hypothesis? There is no difference. What's our alternative hypothesis? That the expensive brand does in fact be better. It does a better job. So let's just look at a few cases here, and we'll talk about this notion, these type 1 and type 2 errors. So we're going to make a little table here and think about what could happen. So again, I've got my null and my alternative hypotheses up there. Now, suppose we've got some omnipotent being. Suppose somehow the omnipotent being knew the following. Suppose that null hypothesis, suppose that is in fact true. Okay, so suppose somehow we knew that ultimately there is no difference between those two brands of soaps. Or likewise, let's suppose if the truth is somehow known, that the null hypothesis is false, which means that the expensive brand must be better. Okay, that's our evidence at least. So let's think about what can happen here. So let's suppose that null hypothesis is true, right? That null hypothesis that there is no difference. That's what we're assuming to be true. So we go out there and we collect our data and we do our test, and what can happen? So suppose we perform our statistical test, and we come to the following conclusion. And what we do is, and we suppose we fail to reject. Suppose we fail to reject that null hypothesis. Okay, so what that in a sense means is we assume it to be correct. So it says that, hey, there is no difference between those two soaps. That's the ultimate truth. But based on our data, we also fail to reject it, which means we, in a sense, are accepting it, which again means that we are believing, in fact, that there is no difference. So, okay, so let's see. Suppose we fail to reject. So if we fail to reject it, think about it this way. We're keeping it. And that's good because the null hypothesis is in fact true. So the truth of the matter in this case is that there's no difference, right, between the two soaps. That's the truth of the matter, because we know that the null hypothesis is in fact true. Again, suppose somehow we knew that. And what conclusion did we reach? Well, the conclusion we reached was that the conclusion that we reached is that there is no difference. Again, because we're keeping that null hypothesis. We didn't reject it. So what action did we take? The action we took is we buy the cheaper stuff and get the same results. Right? So we've saved money and we get the same results. So in a sense, this is, right, if you think about this, this is kind of a good thing, right? This is good. The null hypothesis is true, and we held on to that belief. That's what we did. Now, what else can happen? Suppose that null hypothesis is true, right? Suppose it ultimately is true. There's no difference. But we look at our two datas, we perform our statistical test, and we decide to suppose we decide to reject that null hypothesis. Oh no. So in this case, suppose we do our test and we actually reject that hypothesis. Now, the truth of the situation is, again, that there is no difference between the two soaps. Now, the conclusion that we came to was that the more expensive stuff. So the more expensive stuff was better. Right? That's the conclusion we came to, because we're going to reject that belief that there was no difference. The truth is, there is no difference. So what's the ultimate action that happened? Well, we've just wasted money. Right? We've just wasted money is ultimately what's happened. So in this case, that's kind of quote unquote, this is my terminology. I'd say this is bad. We don't want this to happen. And what this is called is when we reject something that we should have kept. This is what's known as a type 1 error. So that's where we get this type 1 error. We reject something that we should have held on to. Okay, so let me put this in here real quick. I'm going to wedge this in here. This is known as a type 1 error. Okay, so what else could happen? Now, suppose that the null hypothesis is false. So we're believing that there is no difference between those two soaps. Suppose ultimately we know that, well, that's not correct, which means the more expensive stuff is better. And again, what could happen? Okay, so suppose that the truth is that null hypothesis is false, and we examine our data, we perform our statistical test, we do the same thing, and we fail to reject. Suppose we fail to reject that null hypothesis. Okay, so the null hypothesis is that there's no difference, but that's not true. So again, what's happened? Well, we've sort of made a bad decision, right? We've made a bad decision. So let's go back and look at the same thing. The truth is the more expensive stuff. So the more expensive stuff is better, right? It's worth spending that few extra dollars. You'll get much better cleaning. You'll be much more happy, and maybe you'll save money in the long run because you use less. But the conclusion that you came to was that there's no difference. You said, there's no difference between the two. Let's just keep using the cheaper stuff. So what's the action? You get inferior results in the long run. Yeah, you save a few dollars. Maybe that's good. But suppose in this situation, you're ultimately concerned about the quality of your cleaning. So the action, well, you're getting inferior results ultimately. That's not good. Well, what we've done in this case, we've messed up, and this is called a type 2 error. So it's kind of like a lost opportunity is how you can think about a type 2 error. So a lost opportunity. The data said you should do something different than what your null hypothesis suggests, but you said, nah, I don't care. I'm going to do what the null hypothesis says anyway. I'm going to hold on to my what seems to be an incorrect belief based on the data that I have. All right, last but not least, suppose that the null hypothesis is false and we reject. Suppose we reject that null hypothesis. Well, in that case, that's good, right? It's not correct to believe that null hypothesis. Our data says, don't believe it, and we say, okay, we don't believe it. So what's happened? Again, the truth of the situation is, again, the more expensive stuff is better. So the more expensive stuff is better. Now, the conclusion that we came to in this case is that the more expensive stuff is better. We said, yeah, that is that is in fact correct. So the action, we are happy. We buy the good stuff. We buy the good stuff. And by good, I mean expensive. We buy the good stuff and get good results. We're happy as can be. Okay, so this is the the notion of hypothesis testing. You've got two different mutually exclusive hypotheses. And what we're going to do is we're going to try to look at some statistical evidence that suggests to us that either one of those beliefs is correct or incorrect. And that's going to give credence to the other one being correct or not correct. That is loosely the idea here. We're going to talk about a little bit more terminology in my next video, and then the one after that will actually start performing a statistical test, one of these hypothesis tests on some actual data. We'll go through the computations and really start doing the nitty-gritty.